HSTEM is really a way to showcase how important research in the health fields is to Michigan Tech.
The building itself, it is a 3-story, 65,000 square feet addition to an existing adjacent chemical sciences and engineering building.
I think the university was very smart in placing this right off of Husky Plaza. And I think placing that building there really doubled down on the university's vision and goal and made a wider impact than just the building itself.
The students made the place their own right away. They were so excited. And I think where we see it now is you see them hanging out. They have their space where that's truly their own. It's the community now. And when we're giving tours and recruiting students, it's huge. The students are like, wow, this is an amazing space. I can't wait to come here. Now we are in the center, we're in the heart of campus, and with that has come new collaboration. So it's really easy for me to work with biological sciences. We do a lot of collaboration, both on the teaching and the research side. I have engineering students in my lab. I have human factors and psychology students in my lab. I have kinesiology students, and they come from all walks of life and all career goals. So we are really providing them with a multidisciplinary environment where they are learning how to interact and work as a team in the same way that they're going to be expected to do in real life.
All of our other buildings are either based in academics or based in research. And having this collaborative building right in the center of campus, I'm really hoping will be a model going forward in the future on how to work together to expand research and academics at the same time. Our education mission is by far the most important mission that we have, but we recently were named a Carnegie R1 institution, demonstrating also that our research mission is also extremely important to us.
We have a lab upstairs that houses our experimental setup, which consists of a left heart simulator. That left heart simulator, which is in-house built, custom made, we deploy heart valves and we assess them under pulsatile conditions similar to physiological conditions. We also use particle image velocimetry, where we shine a laser on our fluid and we seed it with fluorescent particles. We can track the movement of these particles and we can assess the resulting velocity field and the fluid dynamics to assess the performance of these heart valves.
My research primarily focuses on falls and human mobility. I'm really interested in having people fall for science. When people lose their balance, how do we find out how they recover it and what equals a successful balance recovery strategy?
On the ovarian cancer front, I am interested in understanding how do cancer cells actually evade the therapeutics that have been designed. Cancer is such a multivariate system, so what I want to do is build the platforms here so the students here start filling in the gaps that are left.
We hope to provide novel heart valve designs that would overcome the drawbacks of currently available heart valves devices. We hope to understand from a fundamental point of view why diseases happen and assess effectiveness of therapies.
Having that fall arrest system, that's going to allow us to look at clinical populations and challenge them to experience losses of balance like they would in their home environments or their work environments without the risk of them actually being injured. I think that there's 4 major collaborations that have stemmed in the last 6 months out of the availability of the space. And now that people are seeing it, this is the beginning of a lot of really special things that you're going to see coming out in the next few years.
The idea of this interdisciplinary building did come from the highest levels of the university. They realized financially they couldn't build 4 or 5 buildings. It's really important to have flexible labs to future-proof the building because institutions build buildings for 50-year lifespans. We have to make sure that the project can grow and adapt because we don't know where science is going to go.
The original design of my lab was meant for a chemical engineering lab. I have adapted it to a molecular biology genetics lab. With an empty lab, I was able to figure out exactly where all of my instrumentation needed to go. We moved within a day, maybe 24 to 48 hours to have a fully functioning lab in the shared space that wasn't even designed for what I do. And I know for the future that if my research takes me in a different direction, I know the lab can accommodate that.
The anatomy and physiology lab had a really interesting oval teaching station that we call the oval air station. That oval shape just sort of makes collaboration and coordination a little bit easier because those corners in one's mind present barriers. So by eliminating that corner, we make it easier for people to slide around those spaces and collaborate and coordinate more deeply working on a student project.
We have a top-of-the-line anatomy and physiology lab. I walk by that every day to my research lab and watch as students are learning about the kidney system or the skeletal structure, everything down the line.
At MTU, they had a very separated, siloed approach and wanted to break down those silos, bring people together, and start communication.
Now that we have research on display where the students can just walk through and see the graduate students doing their research, they're more aware of it. Before we were doing it behind, cinder block walls. And so they had to know to ask. And now they can just say, hey, what's going on there? That's pretty interesting.
The computer modeling lab at Michigan Tech was a really unique space because it combined both a research area for the researcher and his learning and teaching space.
And it's really exciting in this space to work with my organisms of choice in my lab, do the molecular biology, do the genetics, do the biochemistry, and right next door, do the sequencing. My students access to $500,000 instrumentation allows us to do 20, 30 times more than I was able to do as a PhD student.
In all of our projects at HED, we look towards having a certain amount of sustainability just built in as a baseline in all of our projects. And the entire design team was really focused on that. We were able to achieve gold, which is fantastic, especially in a science facility in a remote location.
It's important to have LEED certification to Michigan Tech because we want to be a leader in this area on sustainability. And so making LEED certification for our buildings allows us to both show that this is important to us, but also our utility costs to make the buildings more sustainable to function also.
The team at HED was invaluable at providing feedback and oftentimes really creative solutions to, keeping the researchers happy and as well as keeping the building functional.
And HED really listened to what our needs were and really thought about the ways to solve it. We gave them a huge challenge of adding a brand new building attached and renovating an existing building. And they really were able to come through on a very difficult set of circumstances to design a building that we are really happy to use.
The tools that Grainger used throughout the project to make it successful started during the estimating and pre-construction period of the project.
We were sharing our BIM model directly with the contractor and with subcontractors. And then during construction itself, Grainger Construction used a technology where they walked the site every day and they had a video. And at any point in time, you could stop that video and you could spin 360 and see the construction site.
We were also able to capture the history of how things were put together. An example would be before we install the drywall, the capture would have everything shown that's in that wall. So if you had a question about where something was roughed in mechanically or electrically, you'd be able to go back to that capture and see that.
Grainger's use of technology, specifically the Procore software that we use, was invaluable, especially for communicating these changes of the drawings and the design to the researchers or the end users. That was a huge benefit to the project.
Having our foreman for each trade with a tablet on site was very useful because as soon as something was updated, they had it at their fingertips. So they were always up to date on anything that changed or revised on the project. We ended up inviting about 800 contractors to bid on the project. Realizing that we were in a remote area, we spent a lot of time deciding how we were going to right-size bid packages and buy out the project. It was important to us to make sure that we had as much local participation as possible. Electrical contractors are an example of how we were able to collaborate to successfully get that package awarded for local participation. We had 2 contractors go together as a joint venture so that they were able to bid the job. And in the end, they were successful with their bid and were awarded the project.
and having those local contractors here 3 miles away to come back and help out if there's an issue it's been priceless.
There was this cohesive team between Granger, HED, and Michigan Tech, and that all different parts of that team did a really good job at keeping the ball moving forward and communicating, and there was really an amicable kind of collaboration, and I think the project really benefited from that we were all, at the end of the day, focused on the same goal of making this building as best as we possibly could.
The level of collaboration on this project, I think, was above and beyond. The experience overall, it truly was amazing.
As an alumni and now transitioning to a staff member here, I think this building makes me feel really proud of the Michigan Tech community. And I'm just really proud to have been a part of it and to see everyone benefiting so much from this building.
The people that are working in this building are really excited about it. It is by far the most modern facilities on campus. They love the variety of the spaces available so that they can conduct the research in the safest way and the best way for them. When we give tours, you can just see the eyes of the students, the eyes of their parents get very excited at seeing this very modern building in the heart of campus. This space just exemplifies what Michigan Tech has always thought is important, and that's teamwork.